Alright, so we're here to show you how to find the centre of mass experimentally. Now you'll be relieved to know it's probably a bit easier than the calculus you've been doing to do it theoretically. So the way that we can do it is here I've got this lovely whiteboard and we're going to find its centre of mass. And the way that we're going to do it is I've got this nice string that's just going to fall directly down because it's got some weights at the bottom. So what I'm going to do is I'm going to start out by I'm going to pick a point by which I'm going to suspend the whiteboard. So I'm just going to let it hang freely, and so you can see it kind of dangles backwards and forwards like that. Now when I put the string through it, that string will pass through the centre of mass. So know the centre of mass is somewhere along this line. So Alan, could you please draw in the line? I'll just hold that in place nice and firmly.
Down one there.
Thank you. Alright, so we know the centre of mass is somewhere along that. So to help us find it, I'm now going to suspend it from a different point. So I might let it kind of dangle. Oh. So there we go. So we know our centre of mass is somewhere along that line as well. So Alan, could you please draw in the line there? Okay, and then if we have another go, so you can, theory it would be right there, but it helps if we put in an extra point, so that way we can see how accurate we are. So what I might do is I might pick the top bit here. Oh. And so it looks like there's our centre of mass, so I'll hold that.
Once again, I'll come down that side there. Oops. Missed.
So we can see our centre of mass is pretty much at this point here. Maybe we'll do one more just to double check. It doesn't help if this is actually swinging like a pendulum, but... Alright, I'll pinch that down.
And I'll come down this side.
Alright, so now our centre of mass is there. But you're probably thinking, this is a very strange place for the centre of mass to be. Surely it would be in the middle of the whiteboard. But what you don't know is that I've actually taped some weights onto it at the back. So the centre of mass isn't in the middle, instead it's a bit lower down, which is what we see here. And that's how you find centre of mass experimentally. Note, it is actually possible for the centre of mass of an object to be located outside of that object. The classic example of this is a boomerang. If you have a look, there's a boomerang illustrated here, and the centre of mass is actually in the middle here, which is not part of the boomerang itself. Suppose an object has a base on the ground. This could be a series of legs, like when a human stands, or like a tripod, or it could just be one wide base at the centre of the object. If the object's centre of mass is not directly above a point that is bounded by its base, then it will tip over. So for example, if the signpost at the end looked like this, the centre of mass would not be directly above the base, and this would cause the object to tip over or fall over. This is why it's harder to balance on only 1 foot than it is on 2 feet. When standing on 2 feet, you can establish a wide base. And as long as your centre of mass is within that base, you will not fall over. When you stand on 1 foot, your centre of mass must remain directly above that point, otherwise you will fall over.
Okay, similarly, if you are standing on a post or a pole or a beam, you have to keep your centre of balance directly above the beam or the post, or you will in fact fall off.
For ballet dancers, they can stand on point, where their base becomes just the tip of their toes, which is very small. In this case, in order to stay balanced, they need to keep their centre of mass within a very narrow range, which is a very impressive skill.